Okay. Uh, Today we are continuing with our lesson 8. And for this particular lesson now, we are going to look at how do we calculate the area of a sector and a segment. That is where we are going to concentrate how to find the area of a sector and the area of a segment. But as we start, I'm going to ask you to first try out for me this number, this activity. Yeah, everyone, first try out on your own. We are going to do it together, but I want each one of you to first try out on your own. They're telling us we have a designer that is making a pendant, and they're telling you that it is in form of a circular disc with the diameter of 10. Now, okay. Now, like we said earlier on, when we are making designs or in industries or in any department, you'll find out that the materials to be used or the material they are going to use will always depend on the area. So for you to be able to estimate how much material you need for a particular thing, or in case maybe it is these jewelry things, maybe metal, maybe the gold and the rest of that, you need to know the area that it takes. So this person here, those who don't know what a pendant is, I think that it is like those necklaces, those necklaces that girls usually put on, or boys, but I think it is so common in girls. So it looks like that. It is something that is in a circular form, but inside it, there is always like a hole. So they are telling you that this jewel, it has a circular disc with the diameter of 10. So meaning that the distance here is what we have as 10, that bigger one, and it has a circular hole cut out of it. The radius of the hole is 2 centimeters. So they're telling us that the inside one, its radius is 2 centimeters. Members, what is the radius of the bigger one? What is the radius of the bigger one? What do you have? Okay, I'm waiting to look at the answer here in the chat. 4, 5, 5. Okay, yes, it is 5 because they have told you that the diameter of the big one, of the circular thing, it is 10. So in order for us to get the radius, we shall always divide by 2, so it is 5. So the radius of the bigger one is equal to 5. So in order for us to find the area, now the area that is being covered, remember this, it is like this. They're asking us, what is the area of this part that I am shading? So meaning that in order for us to get it, we are going to find the area of the bigger one minus the area of the whole. So what are you going to do? We are going to find the area of the big one. So I will say area of the big. So we know that area of a circle is always given by pi r squared. And please always take note, whenever they don't specify your pi, always go on and use 22 out of 7. So we shall say this is 22 out of 7 times our radius we had as 5 squared. So when I continue, I'll have 22 out of 7 times 5 squared, which is 25. So here, when you multiply, remember here you multiply the numerator as 22 times 25, you'll end up with 550 out of 7, which when you divide, you end up with something like 78.571 So here I would advise that when you are writing decimals and the number is still continuing, at least you can write to 3 decimal places. So this is going to be centimeters squared. Then after finding that, find out what about the area of the small one? What do you have? So in order for you to get the area of the small one, you are going still to do the same. That now you have the radius. I will say area of the small part, like that wall inside. This one here. What is its area? So still you say area is equal to pi r squared, which will give us 22 out of 7 times the radius. But remember, for it, they gave us the radius as 2. So I'll say 2 squared. So this will be 22 out of 7, then times the 4. So 22 times 4 divided by 7, we end up with 12 0.5714. So in order for us to find what is the area of the pennant, this area here that I've shaded, it means that we shall say that the area will equal to the area of the big minus the area of the small part. So this will give us 78.5714 minus 12.5714. And that one will give us our answer as 66 centimeters squared. So that is the area. So those people who are going to go into manufacturing, you're going to be maybe making things like clothes, like you're going to be maybe tiles and other things. Always, the area of that thing you are making will always be very helpful in order for you to estimate the cost of the material you need, in order for you to estimate the way you are going to price. Because if you buy maybe a big roll, maybe at 200,000, and the material and what you are making is almost taking a quarter or almost everything, then you need to look at the area that it covers vis-a-vis the material, and then you learn how to do the pricing. So knowing the area of a given thing helps you a lot in cost estimation, pricing, even weight calculations. Those who have boarded the plane, the weight of the things you are carrying determine how much you are going to pay. So it is really very important in material estimation, weight calculations, costs, and pricing. So the ideas we are going to look at now, when we are looking at the sector, when we are looking at the segment, will help you in real life when you come into the manufacturing or when you are doing something. So are we together? Are we good to continue? Are we on the same page? Okay. Okay. I think we're on the same page. Okay. Now we start on what we call the area of a sector. The reason why we are doing the other previous number, I wanted to just remind you about how to obtain the area of a circle. Now here we are going to look at the area of a sector. Earlier on, we said that a sector is that small portion. Whenever you share a cake at home, whenever someone is celebrating a birthday, that small portion they cut from the whole piece of the cake and they give you is what you call a sector. And we say that when it comes to a sector has mainly two important things. It is always enclosed by a radius. So this is our radius, which we are calling R, and this is our second radius. And we say that this small part, this part they give you here, this is what we always call the minor sector. And then the bigger part that remains is what we call the major sector. So in order for us to be able to obtain the area for this for a sector, one, we notice that the sector you notice that this figure we have, or the sector, comes from a circle. But we know that when I have a circle, the total number of degrees I turn around a circle are 360 degrees. So when I cut out a small portion, let me say this is the portion that I'm cutting out. It means that when I cut it out, I'm removing this. I'm going to have this uh, I'm going to have this and something like that. So if this small portion I've cut out is maybe, let me say it is 60 degrees, it means that the number of degrees that are remaining for this particular one is going to be 300. So whenever we are cutting out or whenever we are going to be finding the area of a sector, area of segments, we are going to be using angles to know how much portion has been removed. Is it half Is it quarter? Is it 3/4? Such that we know how much area is going to remain. Hope we are there. Now, if the angle here that the radius is making is theta, it means that if I want to obtain the area of this part here, of this small sector, it means that I'm going to say that the area of that sector, but here particularly of the minor sector, is going to equal to the angle I have here is theta divided by what are the total number of degrees in a circle, that it is 360 degrees. Then times, since it comes from the circle, I will say pi r squared. The reason why I put theta out of 360, I want to know the portion that has been cut out. So when someone here gets for you 60, it means that the portion she has given you is going to be 60 out of 360. So when you say 60 out of 360, you'll be able to obtain your answer that someone has given you 1 out of the 6 parts. So it is 1 out of the 60 parts. When you look at the cake I have this side on my right, this is 1 part, this is 2, 3, 4, 5, 6. So meaning that the person out of all the 6 parts, he has picked for you 1 out of 6. So meaning that the angle I have here is 60 degrees. So in order for us to find the area of the portion that has been given to you, we get what is the like the quantity, what is the fraction that the person has given you out of the whole thing is what we are finding. So that's why we have theta out of 360 times the area of the whole thing. Take an example like at home, in case maybe this is your portion. You have 1, 2, 3, and 4. So if you want to know how much area has been given to you, you will say that how many parts do we have? We have 4 parts. But if they have given you 1 part, you will say 1 out of the 4 parts, then times the area of that particular thing that they have given you, of the wall where the thing was made. In case this was maybe 8 by 2, so here we say times 16, and then you get your area as 4. I don't know whether we are on the same page. Kindly let me know in the chat whether we are on the same page concerning the formula. Are we on the same page? Okay. Okay, people are saying, pardon, sir. Okay, yes. So I want to repeat one more time that whenever we want to find the area of this small portion they have given us, we know very well that the area of a circle is always given by pi r squared. But if you are interested in just one small thing, one small portion, always look at the angle you have. This angle you have is what is going to determine is what is going to help you to find out the area that you have. So to obtain it, I will say theta, which is the angle of that particular thing I want, divide by 360 times pi r squared. So this is the area for the minor sector. In case it was for the major sector, let me say now, area of the major sector. Still, the formula remains the same. The only thing that now I want people in the chat to tell me, members, this is our major sector. This is our major sector. What is the angle of the major sector? Remember here we have said is theta. What about the major sector? What is the angle? What is the angle? I'm saying this is who? Yes, Desire?
It is 2 theta.
It is 2 theta? Really?
No,
Really?
it's 350 theta.
It is?
Oh, 300.
300. Okay, 300, that is when you have considered the 60. But here now I've just given you unknown. I've given you unknown. Okay. Desire, can you think? Okay. Now, members here, don't consider the 60. 60 I was using it just as an example. Okay, but I know I've seen. Okay, okay. Yes, Calvin.
Okay, for us to find our angle, the remaining angle of the major sector, we are going to get 360 minus theta.
Okay, good. Thank you. So you'll get 360 minus theta, then divide by 360, then everything times the area, which is pi r squared. Remember here, the way people are getting the 300, remember if this is, you consider it as 60, the angles that are remaining, you are saying 360 minus 60. But here now, if we don't have 60 as our specific angle, it means that this 60 is what is representing the theta. So you say 360 minus theta. So always, when you meet such question, always we need to look out, are they asking for the area of the minor sector or the major sector? So always you read the question and then you answer accordingly. So can we first take note of that? Yeah, let's put something down quickly and then we start on some examples. So when you finish, you let me know through the chat for us to continue. Okay, seems some people have finished. Okay, continue. May I ask you to first try it out on your own? Hmm. Okay, so people are trying. Okay, someone is getting 4. That is Victoria. Chisach, have you, sorry, Desire, have you got the answer?
Also, I was asking that could you please put back the previous slide? I had not made a screenshot yet.
Okay.
So I'm done.
Okay. Okay, hope everyone is trying. After, feel free to put for us your answer in the chat. So first in Victoria. Okay, it seems people are getting 4. Someone is getting 12.5. Okay. Okay. I've seen we have tried and we have different answers. So we are going to start. Yes, gift. Gift. Okay. Okay. Now, in order for us to obtain, we shall still gift. We shall say that our area is equal always to the angle divided by 360, then times pi r squared. Now, here you need to ask yourself, what is the angle? So you can notice that the angle that was given to us was the 40 degrees. So I'll come and I say 40 out of the 360 times my pi, which is 22 out of 7, times the radius, which is 6 squared. So this will give you 40 out of 360 times 22 out of 7 times 6 squared, which is 36. Then when you reach here, you start reducing in any way you feel. Or alternatively, you can decide to first multiply all the numbers you have in the numerator, divide by what you have in the denominator. So someone can decide to say 40 times 22 times 36 divide by 360 times 7. Then you continue. For you, you place your calculator, don't mind. You say 40 times 22 times 36, which will give us 31680, divide by 360 times 7, which will give you 2520. Then you come and reduce. You reduce. So when you have 31680 divide by that, you'll end up getting your answer for our area as 12.571. And then you say, since the radius was given in centimeters, then you say these are centimeters squared. So the people who are not getting it well, I think it comes from the way you went on and I think divided. But let me hope. Now the answers of 12.57, those are the correct answers. Members, hope we're on the same page. The people who are getting 4, I actually don't know how you were getting that 4. But let me hope everything now is okay. 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 Okay, Emma. Okay. I think we can continue. Okay. Okay. Now, sometimes they may need you to come up with the sector, you as a person, to draw it when they have given you some few words. Now, like here, they have told us that a sector of a circle has an angle of 103 degrees. If the circle has the radius, calculate the area of the sector. Now here, always it is a good practice to make your own sketch. After making the sketch, you go on and do the calculations. So may I ask you to first try out on your own still, then we can do it. So first try out. Make a small sketch of how your sector can look like and estimate well how 103 can be. Okay. Okay. It seems people are getting 41, 41.5. Okay. Okay. I think there we are good. Okay. Yes, Shakul.
Firstly, good
Mm.
morning. Miss.
Morning.
First sketch our sector,
Mm.
and if we put in our angle, which is 103 degrees,
Okay.
then our radius that they have given us, which is 6.8 centimeters. And
Okay.
remember, the radius are two, the other side and the
Mm.
other side. Yeah.
Okay.
Then we are going to use our formula for the sector, which is theta over 360 pi
Mm.
r squared.
Okay.
And our theta that they have given us is 103 over 360 times our 22 over 7, then times 6.8 squared. After, we are going to get 103. We are multiplying the upper ones, the numerator, then the denominators.
Yeah.
Yes, that is it. Then after, we shall get the answer as 41.557.
Yeah. Just I wanted to write. I know some people may not have calculators.
Then
Okay.
getting the answer as 41
Mm-hmm.
point
41.
point 579 centimeters squared.
Okay. Thank you so much. Yeah, that is correct. Now, still for this same question, they may ask you uh, of the material that was cut out, like the material that if this was it was a sector, they may ask you for the material that was cut out. So in other words, they're asking you for the major sector. So if at all they're asking for the major sector, the part that was cut out or the part that was not used, then it means that now here it is just a matter of you saying 360 minus 103, you get the number of degrees and then you apply the same method. Members, can I assume we are good for area of a sector? Is everyone fine with it? Okay. Yeah, okay. Now we go to the second one. Lighton, is it a question?
Yes, teacher.
Okay, ask Lighton.
Okay. Good morning, class.
Morning.
I was inquiring,
Mm.
the most correct answer is it to 3 decimal places, or you can just leave it to 2 decimal places?
Okay, and the best one I would recommend are 3 decimal places and more. Why is that the more the number of decimal places, the more closer you are to the accuracy level.
Okay, sir. Another question.
Yes.
Can you round off maybe like this answer that we have here,
Mm.
41.5? Can you
Mm.
round off the to the first? Okay, from 5, can you round
Mm.
5 to 41 and you get 42?
Uh-huh. Now, there you have gone like whenever you get a decimal place, unless you have been told to do so, that write to 0 decimal place, but never commit yourself to write to 0 decimal place if you are meeting decimal numbers in your calculations. So always leave them in a decimal part. Don't write whole numbers if what you are getting is, unless they have told you that write to 0 decimal place. But if they don't, never round off to 0. That one, they will not score you. They will say, no, you have estimated. Because like, just imagine you have scored 89 point, let me say 89.5, and someone who has scored 90, something like this. Here, if they don't round off, here you will not get maybe an ester, but here you'll get it. So that rounding off to 0 decimal place, it's not so accurate. Yeah, never commit yourself unless the question.
Okay, thank you, sir.
Yeah. Yeah, yes, we always need to put the units, always look at the units and put them. What if they're in fractions? Yes, now when it comes to fractions, more so when it comes, you have to reason, you reason and say, leaving it in fraction or not. But for fractions, I wouldn't recommend you to write in fractions, more so if those fractions are very big. So always you write your fraction and then write your decimal place, because it is always very easy to visualize when you have a decimal place. Take an example, you have got maybe 115 out of maybe 900 something. Someone may not easily visualize it unless it is in a decimal place. So if the question you are noticing that they are not in the fraction is not okay, for fractions, basically use them when it comes to probability. That one is very okay when we are in probability. But when we are working out things in even like probability, it is okay for half fractions or percentages. But other areas, reason out most of those big fractions that are not exact. Yeah, for those ones, please write it in decimal. Okay, one more question. Yes, Colin.
What if you written 41.6?
41 point? Yeah. Yes, still that is what I'm saying. That one you are a bit close, but but you are going a bit away from the accuracy. So like if you write to 3 decimal places or more, or 2 decimal places and more, it means you are getting very close to the correct answer.
The correct one.
Compared to when you round off to few. So whenever you terminate the decimal places, it means you're going far away from the accuracy level. So for you to be more accurate, it means you must have quite a number of decimal places. So the recommended one, at least 2, 3, or 4. And when it comes to let me say probability, 4 decimal places are recommended.
Okay, thank you, sir.
Okay. Okay, now we are going to look at our segment, area of a segment. That's where we are going to go. Now, you know very well, we say that when we are looking at a segment is obtained whenever you have a chord. Let me say this is our chord. And we say that whenever a chord cuts the circle, this one is always our minor segment. And now, if we want to find the area of this, what do we need to do? Now, here you are going to have two things combined. We are going to combine a sector and we are going to always combine a segment. So take an example. I can come like this. I can come like this. So when you look at it very well, you are noticing that we have two figures. I have a sector there. I have this as my sector. I hope members can see it. But also, I have a code that is cutting and I'm forming a segment. Please take note, never take this one to say that this is a semicircle. Not really. It's not a semicircle. So this one is a segment and not a semicircle. So never assume that that is a semicircle. Let me find its area. Not really. So always we are going to use the concept of a sector and then the concept of triangle. So when you look at it very, this is our center, this is A, and this is B. So we have two figures. We have the sector and you have the triangle. Can someone share with us, if this is the shaded part, how do you think we can get the area of this shaded part? Can we use the chart? Let me now use the chart and tell us, how do you think? But okay, at also I can pick some hands. Okay, yes, Olive.
Okay, for my think, to get the
Mm,
area of the shaded part,
mm,
you can first get the area of a sector.
mhm,
You also get the area of this triangle.
mm.
Then you get the area of a sector minus the area of a triangle.
Wow, wow, wow. Perfect. Gift, did you have the same? Oh, okay. I think Gift your mic. Yes. Okay, yeah, that is good. So you are going to get the area of the sector minus the area of the triangle. But now, my assumption is that all of you have done trigonometry 2. You have done that trigonometry 2 of finding the area using trigonometry. But let me ask through the chart, assume this is my angle theta. And this is maybe, let me call this one to be A and this one to be B. In the chart, can we put the area of that triangle, how we find the area of that triangle in the chart? Let me see whether people did trigonometry too. How do you find the area of that triangle? Mhm. I want to see whether people remember or whether they did trigonometry too. Looking through the chart, it seems we didn't do trigonometry too, or we don't. Okay, at least Timothy has an idea. Antra Max has put it right. Yes, yes, that is it, Max. Oh, Cynthia, your course has disappointed you. Okay, yeah. Now let us remind ourselves, because now we are going to apply that knowledge of trigonometry too. Now, in your trigonometry too, you learned about triangles, how to find the area of any triangle when there are angles inside. Remember always, whenever you are dealing with triangles, whereby those given triangles are not right-angled triangles, your formula of area is equal to a half base times height will never work whenever you don't deal with a right-angled triangle. This formula for a triangle only works when we have our 90 degrees. But whenever you find that the triangle is not a right-angled triangle, then you need to think about the formula. So one of the approaches you can use is what we call the ones of trigonometry. So, and in trigonometry, you remember very well, your teacher might have told that when we label our triangle A, B, and this is C, this angle here is what we call our angle A. And the side where your angle faces, we call it small a. Then if this is angle B, the side where it faces, we call it small b. And if this is our angle C, the side where it faces is where we call small c. So to obtain our area, we shall say that area, in case, now I want you to pay attention, in case you are dealing with angle A, it means you are going to use the two other sides that have not been, and where A is not the length. So still it will be a half BC sine of A. You look at it very well, that the side where your angle faces, you don't use that side, but you use the other two adjacent sides. In case in case I'm to use angle B, it means I'll say a half. the side where angle B faces, I don't use it. I use the other two sides as SC sine of angle B. Can you put for me in the chat, what if I want to use sine C? How will our formula look like? How will our formula look like? Aha, very good, Daniela. Okay, okay, yes, Virginia. Aha, okay, yes. Now, this is one of the approaches we are going to be using. So here, we are going to have our thing as, it's going to be A, B, and then we shall have sine C. Okay. Yes, Desire.
So I was asking because I knew of a different way, the one they gave us, whereby we say C squared is equal to A squared plus B squared minus 2AB, whether maybe it's cos B or cos something like that.
Oh, that is cos C, but that is for finding length, not finding area. So that cosine rule is used when you are finding length of a side.
Okay, sir.
So when they ask you find the length of this side, what? That is the rule you can use. Now we go back. Yes, Shakul.
Master, I was requesting that maybe you allow me to repeat for me that part.
Have you done trigonometry too?
Trigonometry too?
Mm,
Not really.
not really. Okay, because here I cannot prove for you how it comes about. But what I want you always to remember is that always look at the angle you have. The angle you have, this side where your angle faces is never used, but instead we use the length of the other two adjacent sides. But always you can have that idea. From here, I have base times height. So here you say always that you have your half. Then the other two adjacent sides where your angle is not facing are the ones you use. So you say AB sine of theta. And always here we use sine. We don't use any other thing. We always use sine. Never use cos, never use tan and others. We always use sine because it comes in from the sine angle. From that sine direction. Now, members, I have this as you know that this is our angle theta. And you know that the distance from O to A is our radius, which I can call R. And the distance from O to B is equal to R. Members, can we find the area of our triangle? This is our triangle. This is theta, this is R, and this is R. In the chart, can we put the area of that triangle? I want to see whether people are following. Can we put the area of that triangle? Mhm. I want you now to apply the concept. Hunter, that is okay. Yes, I know. Don't mind about how you type the sign. For me, I'm just looking at to see whether you are picking. Okay, okay, okay. Very good. Okay. Yeah. Joyce, Cynthia. Yeah, I think we are there. Good. So still here we shall say that our area of this is going to be our half times R, then times sine of the angle. So when it comes here, we shall say a half. R times R is going to be R squared sine of theta. And now this formula is what we shall be using for us to get the area of the triangle. Hope we are fine on that. Now we are going to write about area of a segment. Now, in order for us to get the area of the segment, like we have already said, that the area of the segment is always going to be equal to the area of our sector minus the area of the triangle. So our sector, for this, allow me to call this to be theta. Our area of the sector will be theta out of the 360, then times pi r squared minus the area of the triangle, which we have said now is going to be a half r squared sine of theta. But please don't cram the formula. For you need to know how it comes about. That this is our triangle, this is theta, this is r, this is r, and to get this area, you say a half r times r sine theta, which will give us a half r squared sine of theta. So we can first summarize that. So here you feel free to say that this is my O, this is my A, and this is my B. Yeah, some people are saying they are finished. Okay. Okay. I think we are good to try out a number. We are good to try out a number. Okay. Now let me. Okay. Okay. That is our first number. Calculate the area of the shaded region. Can I have everyone first try on your own? You can label it. This is your O, this is your A, and this is B. Our shaded part is that yellow part. So I'm giving you 4 minutes to try out on your own. Okay. Okay, I'm seeing some answers coming through the chat. I'm seeing answers coming through the chat. Okay, that is good. That is good. Yes, Desire?
Just wanted to take through the question when people
Okay. We can start.
Okay. I first said area, find the area of the shaded region. We subtract the area of the segment minus area of the sector, whereby the area of the segment is equal to theta pi r squared divided by 360 times
I beg
a
your
half.
pardon?
I'm
You
saying
see?
to find the area of the segment, we get theta pi r squared divided by 360. Yeah, but I say that 108.
Okay. 100.
I don't first put that.
Okay. Now, if I don't,
I'm going to first work out for the segment. So
now the segment is the shaded part.
I'm first working out for the segment, then I'm going to work out for the area of the triangle.
Okay, now what you are calling the segment is what you call the sector.
Okay, I'm first working out for the another sector.
Okay.
So I'm going to get 108 times 22 out of 7 times 4, times 4 squared. And when I press my calculator, I get 15.085.
Okay.
15.085. Yes, then together area of the the one in yellow is called, the
That is
one
the segment.
yeah, the triangle, together area of the triangle is equal to a half r squared sin theta, whereby I have a half times 4 squared sin theta.
But what is your theta?
108. So when I press the calculator, I get 7.608.
Okay.
So I'll say to get area of the shaded region, I subtract area of the sector minus area of the triangle.
Yeah.
Whereby it will be 15.0085 minus 7. My answer is 7. So let me first press the calculator again. I get 7.476.
Okay,
Yes.
thank you so much. Okay, so that is what I expect you to have, but at least I saw many of you had you had the what? The answer within that. That is very good. So, oh, that was very, very nice. We are going to do another one, but now I'm going to start bringing it to your attention. That always better you do a step by step. A step by step meaning first find the area of the sector, find the area of the triangle, and then subtracting. Why? Is that at times when you want to do it at once, in case you make an error on one step, everything can be wrong. Whereas when you do it in a step by step, even in case maybe you make a mistake on area of the triangle, at least you can be able to score something on the other part. Okay, so hope that is fine. Okay, now we are going to now start applying, because note that the numbers will always be very direct, but you are going to find yourself that sometimes you will need to use your previous knowledge. Okay, now we have another one here. Yeah. Now, when you look at it, you need to think of which approach you can use. I know very well, when you look at it, they have not given us an angle, meaning you need to find the angle. Yeah, but here I'm going to transform it a bit to make it a bit much easier for you to understand. So when I draw it like this, here you have 13. Here you have your 13. And they have told you the base here is 24 centimeters. But remember, in order for you to find the sector, you'll need an angle, the area of the sector. So meaning that the angle is going to be very, very important. So what do you need to know is that when I draw a line, when I drop a perpendicular from the center like this perpendicular is going to be dividing my triangle into two equal parts. Members, you let me know. What do you think the distance, this part I've put here, from this point here, let me say this is your A and this is your B. What is the distance from A up to here, 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 here? What distance shall we have there? Very good. That is 12. This is 12. Very good. Now, members, can everyone be able to find out the height, the distance from O up to where we have dropped our perpendicular? The distance, this is where O is. Can we be able to find the distance from O up to here? Yes, those who don't know, we are getting to 12. 12 is just because from A to O, since this from A to B was 24, meaning that half of it is 12. So your task now, everyone, we are finding out. This is what we have for our triangle. In fact, even if you don't find out the height, it is okay. So this is 13 and this is your 12. Now, can we find the angle here? Can we be able to find the angle there? Let me ask you, let that first be your task. Find the angle there. Find the angle theta for me. Let us see whether people still remember some trigonometry. Hey, okay. I'm looking for the angle human. Yes, I want you to find the angle. What angle do we have? 0.92? Okay. Yes, Jonah?
Good morning.
Yes, good morning.
From my calculations, I've got 47.29 degrees.
47.92. How did you reach it there?
First of all, I looked at this triangle and it is a right angled triangle. So it is good to use any of the methods from Sokato, but before, when I looked at this triangle, we are given the length. Whereof, if I'm to look, is the opposite.
Okay.
And 30 is the hypotenuse. So we are given opposite and hypotenuse and the theta. So we can use sine. So
Sine.
sine theta is equal to opposite over hypotenuse.
I think I am losing Jonah.
Sine theta will be equal to
Will it equal to?
0.9.
Now, that's where we are going to start. Whenever you are dealing with trigonometry, you don't write to one decimal place. So here I expect you to write to a minimum of 4. So I expect to have 9, 2, 3, 1, a minimum of 4.
Okay.
The moment you write to 1, your angle is going to change and you are not going to be accurate. And you'll find that even your final answers are going to be differing whenever you write to few decimal places. Okay, so when we reach here, we shall get sine inverse of 0.9231. And which answer do you get?
Oh, I miss I misplaced the calculator. It is 67.38.
Okay, it is 67.3.
38. Zero.
Now, these ones being angles, we can write to, and for me, I'm getting this. I don't know that it is your calc, 67.38 degrees.
Yeah, it is that one.
Okay. Okay. So here being angles, you can even write it to one decimal place as 67.4 degrees. Okay, thank you. Yes, Virginia.
I used sine rule.
You use
So
sine rule. Okay.
using the
Virginia, tell
extract,
us.
I named I labeled the 90 degrees B, capital B, and the 13 small b.
Hey, where? 13?
Um,
Okay. Okay. Uh-huh.
and then the theta capital A and the 12 small a.
Okay.
Then I stated sine A divided by A divided by small a is equal to sine capital B divided by small b. Then I got sine theta. I continued with sine theta divided by 12 is equal to sine 90 divided by 13. Then I cross multiplied. I got 13 sine theta is equal to 12 sine 90. Then I continued with 13 sine theta is equal to 12, and then I divided both sides by 13, and then I continued with sine theta, is equal to 0.9231. Yes, then I took the sine to the other side, that's sine inverse. Yes, sine inverse 0.9231, giving us 67.38 degrees.
Wow. Wow. Thank you, Virginia. That is very correct. Yes. So members, do not forget sine 90 is 1. So that's why here she remained with only 12. So you can use any approach. Yes, any approach can really lead you to the answer. Okay, now that is, we have got the angle. Now, this angle we have obtained here is 67.4. Now, the same angle will come here. This will be 67.4. Now, members, what is the total angle we have here? Which total angle shall we use there? Okay, what is the total angle you are going to use there? Okay, perfect. Perfect. Okay, so here I expect that we're now going to use 138.4. That, no, Victoria, Victoria, Victoria. Victor, okay. 134.8. So that is the angle we are going to use. 67.4 times 2, it will give us 134.8. Now, members, can we continue and do now the number? Because that was the only thing I needed to take you through. Can we continue and do? Let's now continue and do. Anna Museme.
Yes, yes,
Yes. Are we on the same page?
yes, teacher, I understand.
Okay. What of Daniela? Joyce, are we on the same page?
Yes, teacher.
Okay. What of Emma?
Yes, he is.
Okay. Sabrina. So we are finding the area of that shaded part. Timothy and Trevor, are we on the same page?
Yes.
Okay. What of Gloria?
Yes, teacher.
Are we on the same page?
Yes, teacher.
Okay. Amara, are you there?
Which I'm there, but I'm just joined. I'd woken up a bit late.
Oh,
What's the recording?
sorry.
It's okay.
Yeah, we are trying. Okay, I'm seeing some answers are coming into the chat. 138, 138. Yeah, that is very good, members. If people are getting 138, 138, 138, yeah, if you're not getting that, probably there is something you are not doing right. Yeah, but 138 is very okay. 0.9, I'm saying 0.9248. Yes, that is very correct. That is very, very correct. Okay. Yeah, but maybe for some of our friends that came in a bit, yeah, so I expect you to first find the area of our sector, and we say that area of the sector is always gotten by saying pi r squared, and according to the angle you have been having was 134.8 divided by 360 times 22 out of 7 times the radius of the circle, which was 13 squared. So when you place your calc, I think you get something like 198.8835. Then the area of our triangle still is going to be 1 out of 2 r squared sine of theta, which is 1 out of 2 times our r, which was 13 squared, sine of the angle, which is 134.8. So when you place your calc again, you'll have your answer as something like 59.9587. Then the area of the shaded, and let me hope I'm placing my calc well. So I expect you to have this minus 59.9587. So 198.8835 minus our answer. Yeah, you'll get something like 138.9247. And these are centimeters squared. So those who are not getting it, that's what you had to do. Okay, now we are going to look at another number, but still in the same family. Okay. Oh, Patricia, seems there's a question. Yes, Patricia.
Yes, teacher, on the area of the triangle, after writing the formula, my sine 134.8 is different.
Like your final answer. I wrote my final answer. What do you get?
Okay,
Sine of 134.
I got 0.7095.
Yeah, it is correct.
But then when I get the area of the triangle, it's 100.
Have you divided by 2?
No.
You forgot that too.
Okay.
Yes, Abe.
Good morning, teacher. For me, I'm kind of lagging behind on the first workings that we did for the sign of the triangle. I did not get it.
Sign of the triangle,
like where the 134.8 came from.
What did you get? Okay. Did you get how we extracted this triangle? Where we had 13, we had 12.
Yes, that's where I stopped understanding.
Okay. Have you used have you done trigonometry?
No, we haven't yet studied it.
Even trigonometry 1?
No.
Okay. Now, what do you know how to obtain the height here? Because this is the right angled. So we can say a squared plus b squared is equal to c squared. Do you know that?
Yes.
So meaning our a, say I want to find the height. So I can leave it as our a plus 12 squared is equal to 13 squared. So this will give you a squared is equal to 13 squared minus 12 squared. This will give us a squared is equal to 13 squared minus 12 squared. That will be, I think, 25. Then when I use my, I need to just confirm 13 squared minus 12 squared. Is it 25? Yes. Then you get the square root on both sides and your a is 5. Is that fine?
Yes, it is.
So your height here is 5. Now, this one being a right angled triangle. Oh, but still you will need the angle. Yeah, but this one can help you to find the area of the triangle. Now, by saying that area will be a half, base times height, then you say this is a half, my base is 12, then times 5. So here, you'll end up with 12 times 5 divided by 2, which is 30. But since there are two triangles, you multiply by 2 to get 60. So you'll be close to 59.95. That is the alternative approach you can use when it comes to area of the triangle. But now, for you to get the angle, there is not any way you are going to be able to get it if you don't know SOHCAHTOA. So you have not heard of SOHCAHTOA at all.
I have never heard of it, sir.
Then it's because that is senior 3-term 1 work. That is senior 3-term work. But maybe I will share something such that you can, maybe I will check whether I have any trigonometry video such that you can start learning it.
Okay, thank you, sir.
Okay. Another number that I want us to try out. So let me bring in the idea. Yesterday we looked at this. AB is a tangent. And OB is equal to 8 centimeters. Okay. May I ask you to first try out still? This is 30 degrees here. Let us first try out and we see whether we can get there. We are finding the area of that shaded part. People are trying, okay? Okay. And today we shouldn't go beyond 7. Okay, let me, yes, Kevin,
Teacher, good morning.
good morning.
Teacher, I'm sorry to interrupt, but my sister wanted to know whether our Form 6 are also having their morning preps.
Not yet, not yet.
Okay.
But we shall agree. Maybe I'll find out whether for them they can wake up at 4,
Okay. And have lessons.
if possible.
Okay.
Yeah, I'm going to, okay, let me sample the answers that are coming into the chat. Okay, I know the number is a bit lengthy, but I'm just, okay. 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 I know people are still trying. Let's do. But as we are doing, let me put for you another number such that we can even take it as our homework for today. Yeah, let me be putting for you another number. And please, whenever you look at these circles, do not mind, you don't look at it as, something is very complicated. No, you just need to do what? To interpret it. To interpret. Don't mind about the structure of hope my structure will be understood well. Yeah. Still, you are finding the area of the shaded part. Okay. Okay. Members, let me know through the chat. Do we need to first do this number together? The first one? Mhm. Okay, okay, okay. People are saying yes. Okay. Uh-huh. Yes, people are saying we first do it together. Okay. Let me draw my circle again, but good enough, I've seen someone. Now, this is what you have. This angle here is 30. This is O, this is C. Okay, you can label it. This is B, and then this is what? A. Now, this is where A is. Now, in order for us to get this region that is shaded, what do we need to know? One is you need to remember, how am I going to get, or which angle do I have? You know very that the angle, we say that whenever a radius meets the tangent, this one is going to become a right angled triangle. What does it mean now? When I extract, I have this, I'm going to have, this is my straight line, and I have this. And, oh, okay, I've not drawn it well. Allow me to draw now a proper one. Oh, what? Okay, I want to make it better, because when I don't show you well the right angled triangle, it's going to not to be easy. Okay, now you know that this one is the right angled triangle, so it is something like this, whereby this is where the right angle is, and you have something like this, whereby now this is 30 degrees. So this is like where A is, this is where O is, and this is where B is. Now, what do you need to know? You ask yourself, which sides do I have? They have told you that O to B is equal to 8 centimeters. Now, you need to know, what do I have? How can I get O to A, which is my radius? Because you cannot continue without it. So what are you going to do? You label your triangle that this is my opposite according to the angle. Then, if this is my opposite, this is going to be my adjacent, and this one will be my hypotenuse. So if you want to get the radius, meaning that you need opposite and adjacent. So you go back to your SOHCAHTOA. You ask yourself, what is cos? Cos is the one that relates adjacent and hypotenuse. Why? Because the length they have given you is for hypotenuse. So meaning that it is much easier to use it than going the other side. So now I'll say cos of 30 will equal to my adjacent out of the hypotenuse. So my adjacent is my O to A divided by the hypotenuse, which is 8, and this is equal to cos 30. So to get OA, I'm going to cross multiply, and I'll have my OA equals to 8 cos of 30. So I place, I go on and I ask myself, this is 8 times what is cos of 30? When you place cos of 30, you'll end up with 0.866. And therefore 8 times 0.866, if you want, you can even add on more digits, 0, 2, 5. So when you place your calc, you'll find out that you are getting an answer, which is 6.9282, which you can write 6928. So that is what you are getting. So these are 2 centimeters. Now, after getting that, okay, let me see whether people have a question. I'm seeing some hand up. Yes, Colin and Jonah.
Sir, I'm not understanding where that 8 came from.
The 8?
Yeah.
Like from the question, they told you OB is equal to 8 centimeters.
I not
Here,
seen that, sir.
it is here.
Okay. Thank you, sir.
Okay. Yes, I don't know that. Yes, was it Jonah?
Yes.
Hmm.
For me,
I just wanted to take us through because I had need.
That?
I had got the answer.
Oh, okay. First keep. Yes, Desire, you have a poor background, but you may ask.
It's not mine. It's not mine though. But I wanted to ask that is it a must that, like for example, here at first you told us that we use sin. But I'm saying here we're using cos. So I was asking, depending on the question we have, we can either use cos, tan, or sin, right?
Yes.
Okay. Okay, that's why I was lost.
Oh, okay. Yeah. So it will always depend. It always depends. It always depends on which sides you have. Now, I think, yes, Jonah, you can continue.
Yeah, from there where you have ended. Yeah, thank you. So we can import that length where OA is. After there, we are good to obtain the area of the sector. So area of the sector will be equal to theta over 360 pi r squared, which will be equal to 30 out of 360 times 22 out of 7 times 6.9282 squared. And I got 12.57.
Okay. The final answer?
12.5714.
Okay.
So from there, that is the area of the sector. Now we can get the area of this triangle OAB.
Okay.
So I request that you extract that triangle.
It is here. We are going to use that.
So when I'm to check, it is a right angled triangle, so it is okay to use area as a half base height.
Okay.
So which will be equal to 1 out of 2 times. This time round, our base is 6.9282 times height. Oh, I forgot. I think you can first obtain the height using Pythagoras theorem.
Yeah.
So it will be equal to squared is equal to a squared plus b squared.
Okay.
So
Yeah, that is 1. Yes.
And 8 squared is equal to 6 point. Oh, okay. So A, we don't have it. We are interested in getting that at the height. Yeah, is equal to 8 squared. There it is. Let me place. It is 47.9.
After subtracting?
No, 6.92 squared. So I just give the answer.
Yeah.
I got 4.
Okay. So you get. Okay. A is 4. Okay.
We are free to come back here and put our height as 4. So we multiply. The final answer is That is it. So
Yeah.
that is the area of the triangle, and we have already obtained the area of the sector. So the area of the shaded part is just the area of the triangle minus the area of the sector. Getting my final answer as 1.285 centimeters squared. Yeah, that is it.
Okay, thank you, Jonah. Yes, that is what you have to do. Those people who didn't want to use Pythagoras theorem, you can still use your sign. Yeah, so you come here and say, my sine of 30 is equal to opposite, which was your AB, divided by hypotenuse, which is 8. So you have AB is equal to 8 sine of 30, which will give you also 4. So it doesn't matter what you use, but you always get the same answer. Okay, may I ask you to take us, yes, this one which has the two triangles, take a screenshot and then you try it in your free time.
Okay.
We have two circles that are intersecting. So okay, all people have finished. So we shall end here our lesson. Let me thank you for attending. We shall start from there when we meet again. Then we shall look at some scenarios that will involve a bit of the application of the knowledge. So let's meet again, and let me wish you a good day. Bye, everyone.